Hello dear students of class 10. Hope you all are doing good in your studies. In my last video, I explained you some topics related to lesson number 4, refraction of light at plane surfaces. We'll continue this chapter and today I'll take some more topics, and my first topic is relationship between refractive index and speed of light. You know children, the speed of light is maximum in vacuum and it is equals to 3 into 10 to the power 8 meter per second, and it is denoted by the symbol C. When light enters any other transparent media, the speed of light is less than that in air or vacuum. That means the speed of light is maximum, which is in air or vacuum. In the last video, you also studied the definition of refractive index of a medium in terms of the ratio of sin I and sin R, which was the refractive index of second medium with respect to the first medium is defined as the ratio of the sine of angle of incidence in the first medium to the sine of angle of refraction in the second medium, and the refractive index has no unit. Now, if the refractive index is defined in terms of speed of light in vacuum, then it is called as absolute refractive index. Thus, the absolute refractive index of a medium is defined as the ratio of the speed of light in vacuum or air to the speed of light in that medium. That means refractive index equals to C upon V. C is the speed of light in vacuum or air and V is the speed of light in the medium, whose refractive index we have to calculate. One more thing, the refractive index of a transparent medium is always greater than 1. It can never be less than 1. You know the reason why? This is because the speed of light in any medium is always less than the speed of light in air or vacuum. That means V is always less than C. So if the denominator is less than the numerator, then the value always comes out to be greater than 1. Therefore, the refractive index is always greater than 1. It can never be less than 1. But it can be equals to 1 for air and vacuum, because then C becomes equals to V and the refractive index becomes equals to 1. Now let us take an example. The refractive index of glass with respect to air equals to C upon V. C is the speed of light in air or vacuum, which is 3 into 10 to the power 8 meter per second, and V is the speed of light in glass, which is equals to 2 into 10 to the power 8 meter per second. So C upon V becomes 1.5. Thus the refractive index of glass with respect to air is equals to 1.5. Now children, suppose the light is going from medium 1 to medium 2, not from air or vacuum to another medium. Then the refractive index of medium 2 with respect to 1 is equals to speed of light in medium 1 upon speed of light in medium 2. And this is the third definition of the refractive index. First one was mu equals to sin I upon sin R. Second was speed of light in vacuum or air upon speed of light in medium, and the third one, refractive index equals to speed of light in medium 1 to the speed of light in medium 2. Thus refractive index of medium 2 with respect to 1 becomes equals to V1 upon V2. We can write it like this way: V1 equals to C upon V2 upon V2 equals to C upon V1. C cancel. So this becomes equals to mu 2 upon mu 1. Thus the refractive index of medium 2 with respect to 1 equals to mu 2 upon mu 1, because C upon V2 is the refractive index of medium 2 and C upon V1 is the refractive index of medium 1. For example, the refractive index of water with respect to glass equals to refractive index of water upon refractive index of glass, which is equals to 4 upon 3 whole upon 3 upon 2, and it comes out to be 0.89. Refractive index of water with respect to glass equals to 0.89. 8, 9. Now the next topic is conditions for a light ray to pass undeviated on refraction. Means no change in the path of light when it passes from one medium to the other medium. The first condition is that when the angle of incidence at the boundary of the two media is 0. That is, angle I equals to 0 degree. Like in this case, the light ray is passing from medium 1 to medium 2, and this is the normal. So the ray of light is passing along the normal. So the angle of incidence, which is equal to the angle between the incident ray and the normal, equals to 0. Therefore the angle of refraction is also equals to 0, and the light ray passes straight. That means undeviated. The second condition is that the refractive index of medium 2 should be same as the refractive index of medium 1. So suppose refractive index of medium 1 equals to refractive index of medium 2 equals to mu. Thus, see here the light ray is going from medium 1 to medium 2, and both the refractive indices are the same. So the light ray passes undeviated. No change in the path of light when it is passing from one medium to the other medium. Now the next very important topic, the factors affecting the refractive index of a medium. The first factor is nature of the medium, second factor physical conditions such as temperature, and the third factor is the color or wavelength of light. Now first factor, nature of the medium, which is on the basis of the speed of light. Less the speed of light, more is the refractive index, because as you know, refractive index equals to C upon V. The refractive index is inversely proportional to the speed of light in the medium. Less speed, more refractive index; more speed, less refractive index. Second factor is the physical conditions such as temperature. With the increase in temperature, the speed of light in the medium increases, so the refractive index of the medium decreases. Thus, more the temperature, less the refractive index of the medium, and less the temperature, more the refractive index of the medium. And the third factor is the color or wavelength of light. And you already know the characteristic property of light which is related to wavelength is the color. More the wavelength, less the refractive index. This is because in any transparent medium, the speed of light is different for different colors. In a given medium, the speed of red light is maximum and that of the violet light is least. Therefore, the refractive index of that medium is maximum for violet light and the least for red light. That means refractive index of violet is more than the refractive index of red. And the wavelength of red color is more than the wavelength of the violet color. Thus, more the wavelength, less the refractive index. And less the wavelength, more is the refractive index. Now, the principle of reversibility of the path of light. According to this principle, the path of a light ray is reversible. See this figure. A ray of light AO is incident at an angle I on a plane surface SS dash separating the two media 1 and 2. It is refracted along OB at an angle of refraction R. The refractive index of medium 2 with respect to 1 is sin I upon sin R. Now if the refraction takes place from medium 2 to medium 1, the principle of reversibility requires that the ray of light incident along BO at O at an angle of incidence R in medium 2 will get refracted only along OA at an angle of refraction I in medium 1 and in no other direction than OA. So the ray of light is moving along AO and going along OB path. So when it is following the reverse path, it will move along the same path. Thus the refractive index of medium 1 with respect to medium 2 is sin R upon sin I. So if we multiply the two equations, refractive index of medium 2 with respect to 1 into refractive index of medium 1 with respect to 2 equals to sin I upon sin R into sin R upon sin I equals to 1. That means refractive index of medium 2 with respect to 1 is equals to 1 upon refractive index of medium 1 with respect to 2. For example, the refractive index of glass with respect to air is 3 upon 2. Thus, the refractive index of air with respect to glass will be 2 upon 3. That means it's reciprocal. So children, that's all for today, and hope that you will revise everything done and you will read the chapters carefully and do all the question answers given at the back of the chapter. Thank you children.